All right, so now we're live now, and but they're not yet visible. In other words, the system needs to catch up. So I'm going to launch the countdown right now, and then I'll introduce you, and then you can take it from there. And I'll be sure you trigger me when I need to do the MPC counting.
Will do, Christian. Thank you.
Yeah. Hello, everyone. Have a good afternoon. I hope everybody's enjoying all the talks. I'm here to introduce you Elona Rista, Product Support Manager at Solar Turbines. And it's my pleasure to have her present her presentation, TOPP test, key findings from benchmarking turbine oils via accelerated aging tests. So you can take it away here, Elona.
Thank you, Christian, for the introduction. And thank you, everybody, for taking the time to call in. Hopefully you get some, if not useful, at least fun information out of this presentation. So in the agenda, we'll be talking a little bit about what the TOPP test is, the TOPP test. This has been a collaboration that we have done with FluidTech over the past couple of years, still ongoing, always getting a lot of information and interesting data coming in. But first and foremost, what was the need for this test in the first place? What was the method that we used? And then I'll share a little bit of the macro conclusions or a little taste of the data that we have gotten so far. And if you have joined the presentation that I did last year, you know that I'm a big fan of the audience test. So this is where I would like to put to the test your knowledge of interpreting the MPC results. And lastly, everything else that we have talked about so far, just a quick summary, considerations for interpreting the MPC results instead of taking them at face value. So first and foremost, what was the need for this test aside from just love, the sheer love of science? So when working for turbine manufacturers, but also putting ourselves in the shoes of our customers, it has become increasingly difficult, I would say, in selecting an oil that really fits the need of the customer, but also that performs really well in the field. So even though oil specification sheets give you a lot of information, like you see here in the screens, these are actually two different oil brands that are compared side by side. And a lot of this information is very useful. You need to know what the viscosity grade of the oil is. You need to know what the viscosity index is, whether it passed the toast test, what the initial RPVOT number is for that oil. We are finding that it is not as easy to determine how this oil will perform once it is subjected to the stressful environment that a gas turbine operation, for example, will put it under. And as a customer or as ourselves looking between these two oil brands and trying to determine which might be the better of the two, we find out that there's not a whole lot of difference between the two of them, with maybe the exception of the initial RPBOT number. So as a customer looking at these two oil brands, and this being the only distinction between them, I might think, well, the oil that is starting out with a higher RPBOT number at 1800, 50% more antioxidant, more bang for my buck. Maybe that is the better oil of the two to choose. But we are finding out that in the field, the initial RPBOT number does not really make a difference in terms of both oil longevity, but also protection against varnish formation and deposition. And this is where we turn to the wealth of lube oil data that we get, again, as a gas turbine manufacturer. After testing the oil, we have this entire database of data that we started to look at in order to parse out which oils tend to perform better than others. But this is where we also ran into the difficulty of all the variability from unit to unit in the field. So we needed to start accounting for environmental conditions between two different units using the same oil. Also different operating conditions from one unit to another, but also potential contamination that might make those units different. And this is where we decided that it was best to take a bunch of these oils that we see used in the field, bring them to the lab, and this is where we leveled the playing field. So we are subjecting all of these oils to exactly the same aging conditions in order to start seeing how their own properties compare next to one another. And for this, the TOPP test was the method that we used, TOPP standing for Turbine Oil Performance Prediction Test. And the method was to get 4 vials of 350 milliliters of a new oil, place them in a solid temperature water bath for 12 weeks, for 12 weeks at 120 degrees Celsius, and another analogous test for only 5 days at 180 degrees Celsius to account for that increase in degradation with a higher temperature. And then at intervals, we removed one of the vials in order to run all of the degradation parameter tests, such as viscosity, TAN, or total acid number, RPBOT, ruler, MPC, and others. And so far, we have tested about 18. We're benchmarked about 18 oils, but more keep getting added almost on a weekly or monthly basis. So more to come. And hopefully next year, I'll have even more fun data to share with you guys. And before we jump into the actual data, just a quick refresher for those of you that maybe don't look at oil analysis results on a daily basis like some of us do. So we'll be talking a lot about MPC, the membrane patch colorimetry measurement. This was one of the main measurements that we are using to benchmark the oils. And we also talk a lot about the RPBOT or the ruler, the antioxidant level measurement. As expected, the antioxidants drop over the lifetime of the oil as the oil ages. In addition to that, we look at the total acid number, or the TAN. As the oil ages, again, the acidity, we expect that to increase over time. So this is a very good measurement of degradation. And lastly, viscosity. Even though this is not typically a degradation parameter, we have found out that it is a very good lagging indication of oil degradation. And of course, trend and baseline are important to all of those parameters. So moving on to the fun part, some of the macro conclusions, or like I said, a little taste of what we have found out so far. First finding was that oil color not necessarily related to the oil condition. And here we compare oil A to oil B. Both of them have been aged for about 12 weeks, and both of them are showing very dark colors in just the visual appearance of the oil themselves. But in terms of which oil is in better condition, don't worry, the test hasn't started out yet. Surprisingly, we find that oil A shows a very clear MPC patch, so very little coloration on the patch. But in addition to that, in the apologies for my phone blowing up. In addition to that, the glassware in which the oil was aged shows very little coloration as well, which indicates that there's little to no deposition of varnish in this case. By comparison, we look at oil B, and there's a stark contrast with oil A, both in terms of the darkness of the patch itself, but also the amount of deposition on the glassware as well, which means that this the amount of varnish is not only accumulating in the oil, but also dropping out of the oil and depositing on the equipment as well. So even though these oils might appear exactly the same, it becomes very clear here that oil A is much healthier than oil B. Second, RPVOT retention does not correlate to MPC number. And in this particular comparison between the two oils, we notice that the initial RPVOT at the baseline test that we have taken is much higher for the oil on top. It's an astounding almost 2,800 minutes. By comparison, the second oil, a much more modest RPVOT number of about 1,100 minutes starting out. But then we see the first oil over the 12-week lifetime of the test. It has dropped only about 6% of the RPVOT number, so it has consumed a very small amount of the antioxidant, which, if we are only focusing on the RPVOT, we might think, fantastic, this oil is going to last us forever. But then we turn to the MPC patch and we see that this oil is accumulating varnish at a pretty high rate. So the very high antioxidant level that is in the oil is unfortunately not doing a very good job at protecting the oil from varnish formation. And by contrast, we look at the oil that started with a much more moderate antioxidant number. In addition to that, it does consume the antioxidant at a much higher rate. So by the end of the test, it has retained only 40% of the antioxidant. So it has chewed up a good 60% of the antioxidant that had available. But that antioxidant has done exactly what it was meant to do, and it has protected the oil from varnish formation and deposition, because we see the MPC patch is much, much clearer. Next, viscosity, not always an issue until it is. So there were some exceptions to this test. And we look at the first chart here on the upper right corner. The vast majority of the oils that we tested retain at 120 degrees Celsius test, retain their viscosity extremely well, almost with no change at all, with the exception of this one oil in red, which had a steady trend of increase in viscosity, not desirable for the field. But then we turn to the higher temperature test. So now we are stressing the oil at a significantly higher temperature, and we see that at the end of only 5 days of testing, the viscosity has trended up for the majority, if not all, of the oils that we have tested at a considerable rate for quite a few of them. So we see the blue line here being the baseline of each oil, and the orange line being the viscosity after only 5 days of aging at 180 degrees Celsius test. So again, viscosity, not a problem until it becomes so, and much more acutely when the oils are stressed at a higher temperature. Next finding, we found that a lot of the oils that contain EP additives were showing much, much higher levels of acid generation, so much higher TAN numbers, as well as higher deposition formation, so higher levels of varnish on the glassware itself, in addition to just the patch color. We are seeing this oil in particular that we see here in the far right on the chart. At the end of the 180 degrees Celsius test, so only after 5 days, we see it coming up with a TAN number of above 4, which it's pretty astoundingly high, I would say. In addition to that, we are also measuring the weight of the patch, because if you look at the patch photograph that we have here, it will show you that the color is not the only indicator here. It does not tell us the entire picture. When we look at the weight of the patch, that's where we get a more complete picture of how much deposition has actually occurred on the patch itself. And this is corroborated as well by the glassware itself. Just the amount of varnish on the glassware is much, much more severe than some of the other oils that we tested, not containing an EP additive. So we do suspect that the EP additives in this case were contributing to these high acid and deposition numbers that we were observing. Another one, and probably to no surprise to most of you, is that we have yet to find a quote-unquote perfect oil. While some oils perform really well in some of the categories, they tend to lag behind in some of the others. And so aside from that humbling lesson that, we might be hunting for that perfect oil and we might never find it, we still get some really important information here. The data that we have, it can help us in determining which oils might be best for a particular application. So if we take the example of the spider chart here, and I know it's a lot of data that has been thrown into a tiny little chart, but each arm of the spider chart basically represent a single oil with the 3 parameters that we are controlling for: deposit control, varnish production, and oil life. So we take the example of the oil that we see here at the 6 o'clock position, or the one that I'm calling oil number 2. We see, and another thing that I should point out is that the closer the peak is to the 0 or to the center, the better that oil performed. So we see the gray chart for this oil is very close. So this was one of the best performing oils in terms of life. It retained the RPBOT excellently. But at the same time, it did very poorly in terms of varnish production and varnish deposition. So do we throw this oil out and say this is a terrible oil? Not necessarily. There might be a customer out there that has a varnish removal skid that is hooked up 24 hours a day, 7 days a week, and they are removing varnish out as they go. So maybe their interest is in an oil that can last a very, very long time. This might be a good solution for them. And by contrast, we look at this oil here at the 11 o'clock position, or the one that I've called oil number 1. So this oil, even though it has excellent properties in terms of varnish deposition and varnish production, unfortunately, it has a short life. It does consume the antioxidants pretty quickly. So for a customer that does not mind changing the oil more often and wants to keep the equipment varnish free, or maybe replenishes with antioxidants a little more often than otherwise, this could be a good oil. And as we go around the clock here, many other oils where one or another compromise needs to be made. And so this is where we get to the audience test. And Christian, if you wouldn't mind, this is where I give you a couple of instructions. I will be showing you 2 pictures. So I will show pictures of 2 different oils, or MPC patches of two different oils. One will be called turbine oil A, the other one turbine oil B. And you get to choose which one of those patches is indicating a more degraded oil. If you think turbine oil A, the patch looks more degraded, then you say A in the chat, please. If you think B, then please put B in the chat. And Christian will keep a rough score of the 2. I'll give you a few seconds to put in your votes. And let's begin. Between turbine oil A with an MPC of 18 and turbine oil B with an MPC of 8, which one do you think is more degraded? And I should have had the sound of a clock for you for a few seconds.
Waiting for some responses in the chat. I'm going to vote for A. See if anybody else is everyone hear the question? So if you think A is more degraded, state A. If you think B is more degraded, state B. And in the chat.
I think people joined my chat from last year, Christian, where I tricked them, so they're hesitant now.
We're getting a good numbers here. So we have.
Okay, do we have more A's or B's?
We have 4 more A's than B's.
All right.
5, 6.
Ah, okay.
6
so A won, but A didn't win. So what we found out, and this was a pretty interesting one, is that turbine oil A, the patch is actually from a brand new oil. This is a little surprising, not very usual, but this underscores the importance of the baseline. So we know that for a brand new oil, varnish is not expected there. The coloring on the patch is very likely not varnish. This might be an oil that just leaves a dark stain behind on the MPC, or maybe oil that has some sort of photosensitivity. But again, it underscores how important that baseline for the new oil is, because if we have a customer that puts this oil in the equipment, they don't do a baseline, but 6 months later they take a sample, they get an MPC reading of 25, red flags go up. Why did varnish come in so early? And we are discounting that the delta is only 7 in this case, not 25 or 20. This could be a very important thing that we missed. But by comparison, the turbine oil B, even though it's only at 8 mpc, this oil was stressed for a good 12 weeks at 120 degrees Celsius. So hopefully that doesn't discourage you from giving me more answers, but here's another one for you. We have turbine oil A with an MPC patch of 41 compared to turbine oil B with an MPC patch of 61. So if you think A is more degraded, please put A in the chat. If you think B is more degraded, please put B in the chat, and we'll wait a few seconds.
Some results are coming in.
How's it looking, Christian? Pretty even? One side or the other?
It's pretty close. It's pretty close.
All right, so we have an undecided group here.
Yeah, we have a good mix here of options. Slightly more, let me see, 1, 2, 3, 4, 1, 2, 3. Yeah, it's about 4-4 right now.
All right. So the results, again, I tricked you, but you probably knew that already.
Josh is being, he said C.
So MPC and deposition, not always a linear correlation, as we find out here. So the turbine oil A, and both of these oil were stressed at 180 degrees Celsius for 5 days. Even though the patch is lighter, it shows a whole lot more deposition on the glassware, while the second oil is doing a much better job at retaining that varnish in the oil. It's showing us a darker MPC, but the glassware looks much cleaner. So just another wrinkle in interpreting the MPC results, unfortunately. And last one for the test today. Anybody thinks that turbine oil A with an MPC of 66 is more degraded than turbine oil B with an MPC of 36? Put your votes in the chat, and let's hear it.
All right, so let's see. All right, we started getting some results. Come on, folks.
There's no wrong answer here. I was stumped as well, so no worries.
We have 4 A's to a B so far. And
all right, so votes are for A.
So 4-2 so far.
Well, here we find out that these two patches are actually from exactly the same oil. And this is the progression of the MPC oil went through 12 weeks of aging. We see that it starts out with a baseline of 5, and then it goes up and up and up, as we would expect as we are aging the oil. And then all of a sudden, from week 9 to week 12, even though we are continuing to age the oil more, the MPC color drops. And at first, I only got the numbers from FluidTech. So the first response that I had to an MPC that dropped without any intervention was, obviously we did something wrong, right? Let's retest this. And then the pictures came in, and then it became very clear as to where that varnish that no longer shows on the patch ended up. We see that the glassware is much clearer for the MPC patch of 66, but all that varnish that is no longer on the patch now is on the glassware, and this has a direct correlation to our units in the field, where we might see some fluctuation in the MPC. We think, well, maybe something went wrong there. We don't know what. But it could be showing us that the equipment is now suffering much more than it was at the equivalent of 3 weeks prior. And this points out a very good important point. Again, building a reliable trend line for the MPC, because if we are only testing the equivalent of day 1 and week 12 in the field, we are missing this entire time that could have warned us that the MPC increasing steadily. And the varnish is starting to deposit in the equipment, and we could have taken action much earlier instead of waiting until we are on the other side of this cliff and not quite sure whether 36 means a moderate MPC or a much more serious situation, which is represented here by the amount of varnish deposition on the glassware. So in summary, first and foremost, higher MPC, not always worse. As you saw in some of the pictures, an MPC of 30 delta E and 60 delta E might represent exactly the same amount of varnish deposition on the equipment. Make sure you always pay attention to the baseline. So taking a baseline sample is always very important to take into consideration. MPC values and the actual deposits that are generated by the oil, not always correlated. As we saw, some darker MPC patches didn't necessarily mean that the deposition on the glassware was higher. Varnish can still occur even with very low MPC numbers. In the big picture, so we don't only focus on the MPC, we always try to look at all of the other parameters. So if the MPC is giving us confusing results, it is always helpful to start to look at the tan, the RPVT or the ruler numbers, the viscosity, and ultracentrifuge is also becoming a very good tool, a very good complementary test for confirming MPC results. And ultimately, always build a reliable trend. So here's where testing frequency becomes very important. And with that, I would like to thank you all. Hopefully, we have some questions for discussion, but if not, I'm sure you'll find me in one of the video rooms or chat rooms if you have any questions later that you didn't think about right now. So, Christian, any questions to share?
Yeah, there is a question here from Doug Purnell. I'm showing it right now to everyone. You can see it here, Elona.
Oh, let me get out of my slideshow.
Well, I'll read it. Do you think the particles that are formed in the lighter patch has particles that are getting through the patch due to their size? If so, do you think it would be valued to analyze the solvent post-rinse via spectroscopy?
Oh, I would think that would be fantastic, Doug. In fact, if you are volunteering, maybe maybe you could help us with running that test after the patches, because it is very possible. What you are hypothesizing here is what's happening in real life for that lighter patch to happen. So if the spectroscopy test is something that you propose to find out, I would gladly take you up on it. When the samples are being done at your guys' lab in New Jersey. So let's talk about it, and maybe this could be the next add-on to the test that we have already done to explain some of the results that we have gotten so far.
Then we have also a question here from Jim Birch. What next items do you expect to study?
Well, so far we do have our hands pretty tied with all the samples that we are testing currently and the ones that are still waiting in queue. So we do expect the database to continue increasing. And so far, we started out with those oils that are most commonly used on our own equipment, on the Solar Turbines equipment. But the more samples that we get, we're going to be able to compare, to do a more of to apples comparison. So for example, right now we have synthetic oils, semi-synthetic oils, all the gas to liquid and the mineral oils all bunched in and comparing all of those together. But the next layer would be to compare synthetics to synthetics, minerals to minerals, to make it an even more level playing field, if you will, or a fair comparison.
Great. Let me see if any other questions come up. Is Solar now recommending a full round of testing for varnish, at least annually?
Thank you, Larry. That's a good question, and a little bit of a thorn on my side, because actually for routine testing, we are recommending doing that quarterly, and that includes MPC along with all the other parameters that I mentioned earlier to get, again, that trend for the degradation parameters. And in many cases, I have started asking for ultracentrifuge testing as well to use as a complement to the MPC. as more varnish tests become available, as was presented earlier today, there are the insoluble versus soluble MPC patch tests, then we'll definitely make use of those and determine the needed frequency for those. But as it stands right now, at the very minimum, the recommended frequency that we are giving our customers is quarterly.
Great. Any other questions? Let me see here. Pierluigi, a high MPC of new oil could be suspicious. I would not accept it. It could be a problem over time.
And I agree. I would have the same suspicion if I got a new oil MPC of 18 just to start out with. So that's where I would start to ask some questions to the lab. Do we expect this oil, like I said, maybe there's a photosensitivity that is affecting the sample, but not necessarily the oil that is in the tank and not exposed to UV light. It would need a little more digging to understand why such a high MPC number is coming from a brand new oil in order to determine whether that baseline can be accepted to compare with the further samples down the line. But I do agree, it was unusual, but it was definitely an interesting find that I wanted to share with you guys.
Great, thank you very much. I think we may have time for just one more question. How can we utilize ultracentrifuge as a comparison with MPC? From Elaine.
Hi, Elaine. And I watched your talk earlier, by the way. Thank you very much. It was very good. But in some cases, when we see MPC fluctuating a lot for the same unit, so we get samples over time that are fluctuating high to low, that's one of the cases when we ask to get an ultracentrifuge test to get an understanding of what the insoluble varnish presence is in that particular unit. So is MPC lying to us in the way? Is it one of those cases where the oil is not or the varnish is not depositing, it's just showing really dark on the patch? And this is where ultracentrifuge has become very useful, because in some cases we see an almost clear ultracentrifuge result, even though the MPC patch is showing very dark. And in other cases, the opposite happens, where the MPC patch is still moderate or borderline, but we are seeing a good amount of agglomeration of insoluble varnish in the ultracentrifuge test, and then we can tell that the MPC patch is not necessarily moderate. The actual level of varnish is much more serious than the patch is telling us. So it does vary from case to case, but it is yet another piece of the puzzle that now we have available to us.
So I think this brings us to the end of the presentation. Thank you very much, Elona. This has been a great presentation. I really enjoyed it. And we'll be talking to each other soon.
Thank you, Christian.
So thanks
Thank you,
everyone.
everybody.
Bye-bye.